Good morning. Today we are here again doing our online lessons for any students who want to learn these topics. Today we're going to be solving inequalities and at the same time we're solving equations because both go well concurrently because you can see the contrast between the equation and the inequality. So I have a simple equation here, b, which is a variable, plus 9 equals 15. And on the other side, I have b plus 9 is greater than 15. So we have one, the equation is where it's equal, and the inequality is where it is greater than. So we're going to solve our equation first, and we're going to isolate our variable, and then by applying inverse operation. Again, we're isolating our variable and then apply inverse operation. So b plus 9 is one side of the equation, and then the 15 is another side. So if you draw a line straight through that equal sign, you can see the difference. So on this side, you have your left hand side, and this side, you have your right hand side. So we have to isolate our variable. Our variable is on the left hand side. So we need to be getting rid of that plus 9 in order to isolate the b, which is the variable. So we have to apply inverse operation. For this, the operation that we have is a positive 9. So the inverse of positive 9 is negative 9. So we have to subtract 9 from both sides of the equation, not just one side. We have to make sure the equation is balanced. So whatever we do to the left-hand side, we have to do to the right-hand side. So we have to isolate our variable. In isolating our variable, we are going to subtract 9 from both sides. Again, why are we subtracting? We're subtracting because our equation is an addition equation. And in order to isolate the variable, we have to apply inverse operation. And the inverse of addition is subtraction. So positive 9 minus 9, or positive 9 plus negative 9, the same thing. We are left with nothing. We're left with 0. And it would be technically b plus 0 equal 15 minus 9, that is 6. Now, plus 0 is nothing. So it's the same as writing b equals 6. So therefore, the answer to this equation, which we just solved, is 6. So b is 6. So we could also check it to see if we were correct. And if we check it, we will substitute the value for b back in our original equation. We just found out that b is 6. So it would be 6 plus 9, and then we are going to find out if that is equal to 15. Let's see. 6 plus 9, we know that is 15. So 15 equals 15. So yes, our answer b equals 6 is correct. Now, let's move over to the inequality for that very same equation using those very same numbers. Again, we have b plus 9 is greater than 15. We have two sides of the equation, two sides of the inequality. So right there, we're going to put our line. Again, this is the left-hand side. This is the right-hand side. We have to isolate our variable because we want to know what b is. This is an inequality, so b is not going to be one value. B is going to have a range or a solution set. It's going to have many solutions for this case. So now, we're going to again isolate our variable b by applying inverse operation. So we have to subtract 9 because it's a positive 9. So we subtract 9, and we have to do that to both sides of the equation. In doing so, we're left with b plus 0 is greater than, not equal. In this case, it's greater than 6. B plus 0 is greater than 6. This has no value, really don't need it. So it's going to be b is greater than 6. So think of all the values that are that greater than 6. So if you think about greater than 6, can we use 6? No. So the solution set, so when we think about the solution set, we're going to think about greater than 6, which is going to be 7, 8, 9, greater than 6, 10, 11, 12, and it goes on and on and on and on and on and on. It continues. It continues on. Can we ever stop? No. So we have a big, a long, or big, an infinite, you would say, solution set. But we can also draw this to represent this. Represent what? B is greater than 6. If we draw it to say B is greater than 6, we're thinking about our number line. And we're thinking about all the numbers that are greater than 6. So we wouldn't really go on to the negative side. So we're going to start with 6. We're going to then have 7, then have 8. And we continue. And this line shows that it continues. It never ends. But B is greater than 6. B is not equal to 6. So because B is not equal to 6, we're going to have an open circle right at 6. It's open because 6 is not a part of the solution set. I repeat, it's open because 6 is not a part of the solution set. So therefore, all these numbers are the solution set. Sometimes you'll see it above it. Sometimes you will see it exactly on it. So I want us to be precise as we do our thing. So 6, 7, 8, 9, 10, 11. The best place to put it is right here, and it goes on like this. Sometimes you will have to make sure the line is a little bit thicker so you can see the difference between the number line and the line that you're drawing. So this shows that B is greater than 6. So all these are possible answers to this inequality. Again, if we were doing another one where we have, say, a subtraction inequality, then we would apply inverse operation, which would be addition, and we add it to both sides. So in solving equations and inequalities, we're isolating the variable. And in isolating the variable, we apply inverse operation. Whatever the operation is for that constant, we're going to apply the opposite or the inverse of it to get the answer. I hope you learned from this. Stay tuned for more lessons. Bye.